Hey folks, George Leoniak here back with new geometry. Excited to be back and bringing another video to you. And the past few videos I've done have been all on the geohedron, diahedron. And now those are Earth size models. And now we're going to get a little bit smaller. And through that process, I came up with something that I call the Golden Hexagon. So I'll explain how I came up with the Golden Hexagon. I did a little research on it, and it seems like it was actually a thing. The Golden Hexagon is out there. It's not highly popularized or looked at, but it's amazing because I've actually constructed 3 forms using the Golden Hexagon as the foundation. And it's the Golden Hexagon because the edges are based on 5 proportions, just like the Golden Rectangle or even the Pentagon shape. So I'm going to describe all this in the video. I'm looking forward to sharing these little forms here. I'll wait a little bit into the video to show you the forms as we go into it. But for now, let's start up the video and I'll share my screen. I've got the presentation set up here, and I'll explain what is up with what the Golden Hexagon is all about. So the Golden Hexagon, of course, any shape that's got 6 sides is a hexagon. This maintains the 120-degree angles. And, the geometry and the mathematics in this are really fascinating to me. The reason I came about this form anyway was when I was creating the diahedron form, which is this little small image down here. And this is what it looks like in its full form. I realized in doing the math to figure out some of the lengths of the edges, down here I came up with an edge that was phi and root 2. So I was like, hey, well, why don't I just construct a hexagon shape that has an edge here of 1.618. Of course, that's phi. And I'll just make the other edge here 1 inch. Okay, so that was easy to construct. I put that together. I didn't realize at the time what a kind of journey it was going to bring me on, because now, since the diahedron video about a week and a half ago, and even prior to that a little bit, I've just been steeped in understanding and learning more and more about what this Golden Hexagon has to teach. So the first thing I did within it was, I had the hollow shape. And then, I made these cross lines here, which made a smaller little triangle down in the middle. Now that there divided this segment 1.618 into a 1 inch length and also into a 0.618. So that little triangle at the middle is equilateral triangle with all the 0.618 reciprocal of phi ratio there in relationship to the 1. So the side is 1.618. Now, that was pretty neat. The whole length of this is 2.618. And anytime you're dealing with phi, it's just bound to show up everywhere. But I didn't realize that when I drew in these lines, going across here on the Golden Hexagon, that cross one another here, the blue line, amazingly, that turned out to be the square root of 2 right here. This segment length right here, I believe that's in green color, is the square root of 2. And this is then the reciprocal side in phi ratio, because this is now dividing this line in the square root of 2 in relationship to that. And that whole length is a number that, when I first did the math to figure out what this length was, I came up with 2.288 and, a string of other numbers. And I had no idea what the significance of that is. And you'll see in some of the subsequent videos, because I have a few planned out, that number is going to become highly important. But that number is the square root of 5, which of course is a really important number for phi ratio, plus 3. and that gives you 2.288. And of course, now if you were to divide the square root of 2, or divide this number 2.288 by the square root of 2, you'll come up with the golden ratio of 1.618. So I just found it a really awesome integration of some of the sacred geometry, sacred ratios, sacred numbers, of having root 2 in there. And of course, this is an equilateral triangle, which means that this length right here is half the length of the square root of 3. This is 0.866. I believe that's the number there. So I just, I'm not going to just hammer you with the math. I've got a very cool slide coming up, but I just wanted to show you that everything that I like to construct here, I try to figure out how to do that as well, just using the simple basics, line drawings and circles to do it in terms of sacred geometry techniques. A while ago in a video, I posted an easy method of how I like to divide the line quite quickly in divide a line into phi ratio. All I do is, I'll just quickly draw the 7 circles in the seed of life drawing. This should have a line coming down here to indicate that that's the location where you'll draw this line here. This is half of root 5, 1.118. That's half of root 5. And then if you're doing this in a hand drawn, all you do is take your compass needle, which would be here, and your lead there, position it at the front of the center of the drawing, and then just draw a little tick mark. And then this length, if you're starting with the 1-inch circle, this other length here will be the 0.618, and that whole length will be 1.618. I'm not going to go through all the little steps here of how to draw this. I'm just really just showing you how the drawing unfolds here, because what you do is you take that 1.618 measurement that we've got now, and now we just plant that at the spot right here at the edge of the circle. And of course, now we're going to draw these 1.618-inch lines, circles around. And then, we draw these other circles up here. There's a few little steps, but if you want to pause the video, you could replicate this. I do, besides just doing these digital ones, I'll scroll through my notebook to show you this at the end of the video, but I'll just show right now, that the image is easily drawn, and that's showing a double version. And this is just the single one here. I believe I've got the double one coming up in a second. So, as I was doing this, I was like, I've got this snow crystal book by Bentley from Jericho, Vermont, another Vermonter. What else do we do in Vermont besides study sacred geometry and shapes in nature, especially because we've got a lot of snow. He took a bunch of pictures of snow crystals, fantastic, beautiful book. I love to just look at all the pictures. But of course, when I was looking at the Golden Hexagon, I was like, hey, most of those images in this are mostly the typical hexagon shape you see with equal sides. I was like, let me just scroll through the book to see what would come up. So I found a number of images in there that show, and this is just one snow crystal here, that are the Golden Hexagon, or very close to the proportions. But I pulled out this one specifically because it really showed this nicely, that the blue line, this is essentially the Golden Hexagon form that I made here. The blue line here going around the snow crystal on the inner black edge of it, you can, scale it any way you want, but it fits quite nicely. When I draw those red lines, remember these are now 2.618 inches across. This is 1 inch. This is the 0.618, and that's 1 inch. So that's 1.618. It outlines the nice triangle that nature itself has created in the snow crystal. And there is the shape of the Golden Hexagon right here in frozen water, you know? So it's just, that was so cool to discover. I've got another snow coming up, a snow crystal, snowflake to show you that takes this a little bit further. But there's the image, here's the cardboard form, and here's the actual snow crystal form, which has got so much awesome geometry, that frozen crystalline structure, like a somatic image, vibration, frozen vibration in there. So that was really kind of reassuring and exciting on the journey that I was on to come across this pattern in snow. Here was the one I showed you in the notebook briefly, just the double hexagon. Like I said, this is part of a triangle that if you interlock two like this, you know, these double, here's the golden hexagon right here. They are kind of abutting top to bottom here. And it's just one of the few drawing methods that I was working with to come up with design for how to draw it. Now, besides just 2D images that I'm showing you here, this really ballooned out. And in fact, the first image that I drew was sort of based a little bit more on the octahedron structure that I was working with, because I was making it into a 3D shape. And it took a little while to realize, well, essentially what I've done here with this was just create a truncated icosahedron. So the icosahedron is, you know, this is good because it relates to the snow crystal, the water element of the platonic solids. And it's a 20-sided face. It's got the 12 vertices, one of the platonic solids. And, you know, there's already a truncated icosahedron out there, which creates nice little perfect hexagon shapes. But because I'm working with the golden hexagon here, I essentially could recreate that shape, and also with sacred geometry techniques, figure out how to draw it in 3 different views that I call the square view, because it's oriented with the square being the main basis of the drawing. The pentagon view, which of course has the pentagon up top, and the hexagon view, which you can consider to be like the seed of life, flower of life type of view. And that drawing this is what it looks like from that view. The beautiful thing, the most cool thing about this, I'll stop the share just for a minute so I can show you this form. The beautiful thing about this and those drawings was that I actually constructed this first, and then I went back and transposed this into sacred geometry drawings. So, you know, it was cool to kind of reverse engineer it, because a lot of the forms that I make, I'll often create in the drawing first, and then take those measurements and figure out how to make it this way. But now, because I'm constructing a new form that, you know, was basically pulled out of the octahedron ether, you know, pull it out of the ether, to discover that this is kind of like a bona fide form that totally works out. So each of these here are 1 inch, you know, this is all to scale for the pentagon. And then here's the 1.618 edges. And remember, this is a truncated icosahedron, just taking these, you know, chamfering these edges off, truncating it, and, you know, you're left with this. So it took me a little while to just realize that that's what it was. I was wondering what the shape was, and I was like, oh wow, it's just it is an icosahedron with golden ratio sides. So, you know, that was the more complex form. The other 2 forms I'll show you in a moment were a little bit more straightforward, but I was kind of working my way backwards from the octahedron here, from this form. So let's see, let's go back to the sharing of the screen. And I kind of just, I'll just show you a few images here. They're pretty much repeats of the same thing. I just kind of was, you know, geeking out a little bit here, and then just drawing in, you know, the pentagram faces on each of those pentagon faces. And then I was also just drawing in these dividing lines, which create the little 0.618 triangles in the middle. And it just, kind of really just connected all the flat planes with these other lines that are in there. So that was one view. And then here's another one, just experimenting, trying to shade these in a little bit to kind of give them a little bit more of a three-dimensional look. I don't really have a lot of background in how to do that, so I was just kind of doing some guesswork with the shading to see if they worked out. They seem to look a little bit better than the flat versions. But anyway, so that is the 20-sided. Well, it's got 20 plus, it's got 32 sides, this form, plus the 12. And so that's the Golden Hexagon version of the truncated icosahedron. And like I said, here is the truncated icosahedron method for drawing that from the pentagon view. Now, this is really was really cool for me because there's a couple things about this drawing. Let me zoom in a little bit on this picture. Sorry about that. Let's things are flying around here. Let's go into about 150. So the drawing technique for this was really awesome because like I said, I kind of reverse engineered this. I didn't really know how I was going to go about doing this. I was able to do it for the other methods. This was the kind of the easiest method to do it and really the simplest. And it was actually part of the construction method that you would do to just draw the icosahedron. And if you go back to some of my previous videos that describe how to draw all five platonic solids, and especially the dodecahedron and the icosahedron in accurate dimensions. And I really focus on in those drawings, all three of those views that I work with, the square, pentagon, and hexagon, how to, I like to start off with this phi relationship circle, meaning that this blue circle to red circle are in phi relationship. So, I was like, let me just use that technique to get started with this. And then I drew in the 10-pointed star within here and was then able to draw in the pentagons and identify the places where to draw the additional circles, which would then create the places where I can connect the dots essentially on the outside of the original circle of the blue circle here and the red circle, where I can draw these edges in to kind of fill out the rest of the form. So I like to be able to share these techniques with people because now we're able to actually use sacred geometry techniques to create that. And it works, it's not like just because I had an awesome program on the computer to be able to do that. Like I said, I'll thumb through the notebook a little bit, but here's the drawing of it in the notebook. The lines are a little bit fainter for you to see, but when we go to the bigger screen, you'll be able to see that that's it. So essentially, it is like a soccer ball looking type of shape. It's except the only difference is that the hexagonal faces are in this phi relationship, which makes it in some ways a kind of unique form because it carries all these phi-based mathematics with it. And just as like a kind of educational adventure into geometry and math and the bridging of the two and using phi as a part of the exploration was really eye-opening for me, and it continues to bring me deeper into my studies of sacred geometry for sure. So let me go into this other version, and I came to this. I'm going to share the story of how this one came about for the next video, because that's going to take us into a whole nother area. But I was able to basically because we're dealing with the triangular face. And remember, the icosahedron, everything is a triangular face on this, right? So we've got three other platonic solids which have triangular faces. We have the octahedron, has triangular faces. And of course, we've got the tetrahedron, which also has triangular faces. So any of those, I could truncate. So into the, this is a truncated icosahedron and truncated octahedron, excuse me. Truncated octahedron, and normally you'll see that truncated octahedron with regular hexagon shaped faces, meaning all those edges are the same length. And here, once again, I have this now in the phi relationship so that this edge is 1 inch, 1.618. And the other edges are the 1 inch edges all the way around. And it's kind of neat just to look at these next few slides I'll show you, because this one here is actually the pentagon view that I like to draw from, the pentagon view I'm showing you the pentagon construction. And for this form, the truncated octahedron, this one here, what we're doing is we're going to draw it in the square view, which is more related to this octahedral type of symmetry, because now we have the square being represented as the flat surface that we see here, while these edges are sloping away. So you can even make out the outline of where the octahedron would be. And of course, here are the techniques. Once again, if I am drawing this, we'll start out with the red and the blue circles here, which are in a phi relationship. After doing these next few drawings, that relationship, and like I can draw all the platonic solids accurately in there too, that is really like up there with like the Vesica Pisces in terms of sacred geometry constructions. It's like that important, because I'm able to construct these whole new forms based on phi relationships and draw all the platonic solids in 3 different views. So if you haven't checked out that video, I think I called that video not sacred geometry for the next millennium, sacred geometry and unified version, or the simple essence of sacred geometry, something like that. But just check that video out, simplifying sacred geometry to its core essence. And that has this blue and red circle in phi relationship for 3 different views. And I draw all the platonic solids in there completely accurately. And now, in addition, we're adding these other forms in there. I know I just repeated myself again. I guess I'm enthusiastic about the discoveries. So here's the truncated octahedron. This is the method for how to draw that. And now the last one is the truncated tetrahedron, because remember, that's got the triangular faces. And here's the truncated tetrahedron that we've just nipped off those tetrahedrons, which are little 1 inch by 1 inch tetrahedrons all the way around, 1 inch edge length. And this is the hexagons that are left when we do that. So this one also has a drawing method to it. And this is also in my notebook here. I'll show you at the end of how you can draw that. I'd like to, do videos on each of these, because I think that this type of artwork and how it relates to some of the phi relationships, it's once again starting off with the red and the blue phi relationship circles. And just like the one in the pentagon view, these circles inside this red one here is a 0.618 circle, and this one here is the 1 inch circle, and that there is also now in the phi relationship circles. And it's beautiful to me the way that the blue one here touches the inner edge of the red one, and the blue one here touches the red. So you create a totally different pattern than we're used to seeing with the flower of life or the seed of life design when we construct it in this phi relationship type of way. It's kind of like infusing phi relationships into the flower of life, seed of life pattern, which before that didn't really have the phi relationships in there, because I tried to create the platonic solids, which were being at the time said to be created in the flower of life, but the measurements never worked out because that perfect hexagonal structure didn't accommodate for these phi-based relationships that I'm showing you here. So with this method of drawing, we're able to use the universal blueprint of those circles that are of the flower of life pattern, seed of life pattern. You don't need to draw the flower of life at all. You can just keep it all within the seed of life with these phi-based circles, and it opens up a whole new frontier of drawing these new forms and the traditional forms and much more that's out there, as I'm going to show you in the next video. So that's that one here. I guess here's the same image. And once again, when I looked at this, after having studied and taken my phi calipers to like hundreds of snowflakes in the book of Bentley's book here, the snow crystals book, you know, because a lot of them have a really nice hexagon at the middle of it. And I was like, well, where is the hexagon, the golden hexagon in that? Because you could see this is an even hexagon. So I was doing a bunch of measurements, but this width here and this length, I was like, geez, that looks like a lot of those snowflakes. So I decided to layer just that star pattern of the two size stars. So remember, we've got a star here that has 1-inch edges, a 6-pointed star. We got the smaller star inside of that that has the 0.61 inch. I've removed the circles here, and I just layered that over top of a kind of melting snowflake. You know, he had to run in and take the photograph and everything. But, you know, here is, you know, roughly how it lines up very nicely to me, how this inner circle, is the 1.618 or 0.618. That's the 1-inch circle. And how they just kind of frame out the snowflake. Like these widths are often on many snowflakes in phi relationship to the inner width that's in here, like where the black is. And here's the black hexagon where that one is. And then here's the inner hexagon right here, that inner circle connected to, I guess it almost lays over that circle I had on there almost perfectly, you know? So we're back to this awesome overlay of creation of snowflakes, imbuing the phi relationships of this golden hexagon pattern that I was following. So, you know, once again, this kind of comes back to this LO divided by VE. Just shortly before I was creating this slideshow, I discovered this method of how to create these red and blue circles here in the phi relationship, kind of a new way to do that. I showed some previous ways, but I just discovered an even easier way, because remember, all these root drawings that I'm showing you here to draw this, to draw this one over here, that's got it. This one over here has the red, the blue phi relationship circle, and all the little circles are like that. So it's just such a fundamental pattern. Like I said, to me, it's like up there with the Vesica Pisces in terms of a root geometric way of construction that has very little attention out there at all. And I've just really opened up and broadened my horizons when I'm starting off. So just want to walk you through this drawing quickly, because I think that it will be useful to you if you're a drawer of sacred geometry, of how to easily create that relationship. And all you have to do is start off with the 1-inch circle, a radius of, you know, 1/2 inch. If you want it to be proportional, you could do it any proportions you want. Remember, it's the ratio that's important here. It will create that phi relationship, but you could do it at any scale you want. And that's why it's this holographic as above, so below type of ratio that exists within phi. So what you do here is do your 6 circles with the 1 in the center, classic seed of life drawing, right? And then you're just going to go over to the far edge. You're going to divide the center line with these 2 vesicas here, right, that are created from the 1 inch. And that is your 1.7232 root 3 measurement right there. So you've got your root 3 in there, but now you just plant your compass over here, go from the S to the E, get your lead over there, pick up your needle, put it right at the center of the drawing. That's going to bring you out to here for the green circle, right? So you just draw in the green circle. You could even just do a tick mark. What that does is that divides the line, as I showed before, into the 1 inch to 0.618. That's 1 divided by phi and the 1 inch. So there's those measurements up there. And now what that's going to do for there is you take your compass, you take that measurement, you set your compass right here now at this point, and you bring it over to that full length because you want the 1.618. Now you set your compass needle here at the center with 1.618, and you draw your big circle. And that's going to give you a length of root 5 plus 1, and that's 3.26. That's the measurement that is divided by 2 will give you phi. So of course, the radius is phi, and the full length is root 5 plus 1. And this measurement right here, the green circle, is root 5. Okay, so that's 2.23 measurement. So you've got the phi formula, basically. You've just created the phi formula that, you know, I haven't seen a really nice representation of, like, what does that geometrically look like, really simply with a nice geometric pattern with some of the most fundamental sacred geometry pattern designs. And here it is with the seed of life. And the formula for root phi is square root of 5 plus 1. Well, there it is. Divide that by 2, cut this in half. There's root phi, and there's phi on either side of that. So there's the phi ratio. There's your circles. And now you have the kind of way to start off all these drawings with that fundamental drawing, and the rest is kind of easy breezy after that, you know. So yeah, I really had fun putting this slideshow together. I just colored this in real briefly just to give it a little bit of life for that final phi relationship patterning that is, you know, essential to sacred geometry designs. And so yeah, so that was just a quick video. That's really just the it's really just the start of a whole series of videos that I'll kind of be following up with in relationship to this. So let me just do the quick show and tell at the end of this, because a lot of the images were pretty small, or the forms I was showing you pretty small. So you did see this one up close. This is the truncated icosahedron. Your truncated octahedron with the same size golden hexagons is this one. There's the square face. We were looking at it in the drawing like this. And here is your the tetrahedron with the golden hexagon and the golden hexagon truncated tetrahedron here. So I found these really great, awesome kind of meditative tools to just kind of hang out with for the past week and a half or so. Really, once again, I said, it really kind of broadened my horizons and moved me out of just thinking just regular hexagons all the time, and fusing that kind of phi life energy into the regular hexagon that we see. The Bentley book here with all the snow crystals. It's a great one to just coffee table book, they call it. You know, look at all these patterns. If you've got phi calipers, just start measuring stuff in here and you're bound to find some of those patterns. There's a bunch of those patterns that I was showing you that are more like the Golden Hexagon. And it's like the Golden Hexagon is like a early version of those more elaborate patterns, then kind of flower out from there, you know, because even in some of these, you'll find the Golden Hexagon just kind of in them. Let me see if I could just get to one. Yeah, like right here. See, the Golden Hexagon will kind of just show up in some of these more elaborate designs as it blossoms out from there. So there's that. And then let's just take a quick look at the notebook, because my big thing is really making sure that we don't get lost completely in computer technology drawings that we can't replicate and duplicate by hand. I feel like we lose something when we kind of lose that disconnection between being able to figure out a method to draw it. So here's the truncated icosahedron with the golden hexagons. You could see the outline of the circles. I didn't draw them all the way through. There's the inner circles and the outer. So that was a method to do that. Here's the golden hexagon. Here's the double one back to back. I showed you that one in the video. Same basic, same design that I was showing you on that one. And let's see if I've got anything else further on here. The last one here is here's the snowflake pattern. Once again, set up those phi-based relationship little circles, set them up, just start connecting the dots, and there you go. You've got your pattern of the hexagon shape snowflake pattern with the phi-based relationship circles. And then here is the basic drawing that kind of I find is like the root foundation of all those, including the regular platonic solids and just the associated measurements with that. Really simple to do. Just drawing that one over and over again is just a really fantastic way to connect with sacred geometry as a really doorway into some more of these elaborate and complex forms. It all emerges from this simple form with the seed of life at the beginning, the simple design with the seed of life at the beginning of it there. So yeah, once again, I was really I'm excited to have opportunity to share all those discoveries with you. I'm really looking forward to the next videos, which are going to, get out to really like the universal level. So it's kind of like we went from the geohedron, which is over there, and the giahedron at the Earth scale. Now we're going to go out to what is this all going to tell us about the universe and the geometries that are thought to be discussed with that. I've come up with some new scientific researchers that have been, making some new discoveries on the shape of the universe and the clusters of galaxies. And amazingly, these forms that I'm working with took me there, and things that I've been building for months and months and months, a couple of years now, we're all leading in that direction. So it's amazing to see this kind of the creativity and the artistic side start to fuse with the scientific literature and just seeing how that all fits together. So yeah, once again, please check those videos out too. And thanks for sticking around for this one. Until next time, much love and peace.